Hello, this lecture is on another type of logical statement, what's called a quantified statement. Okay? And so a quantified statement is a statement that says that something is either is true or false. It's a logical statement, but it's something that involves either all of a particular type of object or at least one of a particular type of object. So all is called a universally quantified statement. At least one is called an existentially quantified statement. That's not important. That's not what I actually care about. But these are logical statements. Logical statements about all or at least one of a particular type of object. Okay? So quantified statements behave a little bit strangely, and so that's why we're going to talk about them specifically. So some examples of quantified statements: all numbers are odd. This is a false quantified statement. All right, there are numbers that are not odd, so this statement is false, but it's making a statement about all numbers. Okay, as opposed to the other type of quantified statement, which would say at least one number is odd. And this can be phrased in other ways, right? You could say some number is odd. And while this statement is false, all numbers are odd, this statement is true, right? At least one or some number is odd is a true statement, right? Because there are odd numbers, okay? They can be about other things, right? Like you could say everyone loves dogs. That's a quantified statement. It's making a statement about all people as opposed to some people love dogs. Okay? Very different statements. Everyone loves dogs. Probably not true. There are probably people who don't. Some people love dogs. Certainly true. There are people out there who love dogs, right? So quantified statements, this one thing about quantified statements is that this change from the universal to the existential, from all to at least one, is a big difference, right? It can make a statement true or false. And so you have to be very careful that you're using the correct one, right? You don't want to say all when you mean some, right? Okay, and people make this mistake all the time, right? It's a very common kind of exaggeration to say, oh, everybody loves this, right? When in fact there are people out there who don't, right? The other thing to look out for is that when you change these, when you negate a statement like this, people make mistakes with it a lot of times. Okay, so let me talk about what that means. So remember from when we talked about modifiers, when we talked about not, I don't know that I used the word negation, but when we take not a statement, it's called the negation. So the negation of a logical statement is kind of the logical opposite. Right? So anything, basically adding in the word not or is the negation. It makes something not true. So for example, if my statement were the sky is blue, the negation would be the sky is not blue. If my statement were the number 3 is even, my negation would be the number 3 is not even, right? You could also say the number 3 is odd because odd is the opposite of even. So sometimes there are some fuzzy ways, but generally it's saying this is not true. And so with quantified statements, this can be a little strange Because when you negate a quantified statement, negating a quantified statement switches all and at least one. Okay? And so what I mean by that, so for example, if you look at the statement, everyone loves dogs, the negation of that statement is not no one loves dogs. Okay? And a lot of people make that mistake. They say, or another way of saying that would be everyone doesn't love dogs. Okay? That's not the negation of this. That's not kind of the logical opposite. The negation is someone, right? So we've switched all to at least one. Everyone becomes someone. Does not love dogs. Okay? Because what we're looking for when we look for a logical negation is we're looking for a statement that if this one is false, this one will be true. And if this one is false, this one will be true. Okay? And so if you think about it, what does it mean for everyone loves dogs to be true? That means that every single person loves dogs. So if any one person doesn't love dogs, it would make this statement false. So the opposite would be that at least one person does not love dogs. Okay? If this statement is true, then this statement is false. If this statement is false, this statement is true. And that's what makes them logical opposites. Whereas the statement, so not the negation, no one, so everyone, let me write it in a weird way. Normally we would say no one, but everyone does not love dogs. This is not the logical opposite of everyone loves dogs, because everyone does not love dogs is not necessarily true if this is false, right? Both of these statements actually, if you think about the real world, is the statement everyone loves dogs true or false? False, right? Not everyone does love dogs. But is the statement everyone does not love dogs true or false? Also false, right? Because there are people who do love dogs, okay? The logical opposite of this one, right? So these two are paired. This is the negation here. The logical opposite here is at least one person loves dogs. Okay? And so when we negate, we switch from all to at least one, and we change the second part from not back to removing the not, removing the negation. Okay? And so that's the principle of negating quantified statements. So make sure you don't make this mistake. A lot of people make this mistake. Think about it carefully, and so we'll practice this in the homework.